Good day everyone, our topic for today is shortest remaining time first. It is also known as SRTF. So this is a CPU scheduling algorithm used in operating systems to decide which process should run next. So before we proceed, let us talk about what is CPU scheduling. So CPU scheduling is the process of deciding which program or process will use the CPU at a given time. The operating system manages this to improve performance, reduce waiting time, and make sure the CPU is always busy. And next, this is the definition of SRTF. So shortest remaining time first is a preemptive scheduling algorithm. It is the preemptive version of shortest job first. Muna siya ang shortest version sa katong shortest job first na i-discuss sa Picas video. So, the CPU always selects the process with the smallest remaining burst time. If a new process arrives with a short remaining time, the current process is stopped and the new one runs. So let's talk about how SRTF works. In SRTF, each process has an arrival time and a burst time. So the scheduler constantly checks which process has the least remaining execution time. Every time a new process arrives, the CPU may switch to it if it has a shorter remaining time than the current process. So this is our table. We have three processes and we have each arrival time and burst time. So I have a visual presentation here about SRTF scheduling algorithm. So I have three processes. So in process 1, we have a arrival time which is 0 and in burst time is 7. In process 2, we have arrival time 2 and burst time 4. And lastly, in process 3, we have arrival time 4 and burst time 1. So let's execute this SRTF. These following processes. So as you can see here, we have the Gantt chart and result table. So let's talk about the Gantt chart. From time 0 to time 2, the CPU executes P1 because it is the only process that has arrived. At time 2, P2 arrives with a shorter burst time than the remaining time of P1 because SRTF is a preemptive algorithm. So the CPU stops P1 and switches to P2. This is why P2 runs from time 2 to time 4. And at time 4, P3 arrives. P3 has the shortest burst time among all processes. So the CPU immediately switches to P3. This is shown in the Gantt chart from time 4 to time 5 here. And at time 5, P3 finishes execution. The CPU then compares the remaining times of P1 and P2. Since P2 has the shorter remaining time, the CPU executes P2 again from time 5 to 7, as you can see here. And at time 7, P2 completes execution. Only P1 remains, so the CPU runs P1 continuously from time 7 to time 12 until it finishes. As you can see in this Gantt chart below, it clearly shows how SRTF causes frequent preemption and always selects the process with the shortest remaining execution time. And that's all. Let's proceed. Since we're already done with the example, let us talk about the advantages of SRTF. So one major advantage of SRTF is that it provides the minimum average waiting time. It also gives better response time, which makes it suitable for interactive systems where fast execution is important. Since we have the advantage, let's talk about the disadvantage of SRTF. So, the SRTF algorithm can cause starvation because longer processes may keep waiting if short process continue to arrive. It also requires accurate prediction of burst time and causes frequent context switching, which increases overhead. So, let's talk about the comparison with other algorithms. Let's compare the SRTF to other algorithms. So compared to FCFS and SJF and SRTF. So now let's compare the SRTF to other algorithms. Compared to FCFS and SJF, this SRTF is more efficient but also more complex. FCFS is simple but has high waiting time, while SGF is not preemptive. SRTF improves performance by allowing preemption. So in conclusion, SRTF is an efficient CPU scheduling algorithm that focuses on short processes. Although it offers good performance, it has also disadvantages that limit its practical use. And I think that's all about SRTF, and I thank you.